Hey everybody, Joe here. Want to check out a puzzle today by GDC called Harmonic Split. And the rules are normal Sudoku rules apply. That is 1 to 9 in every row, column, and 3 by 3 box. Doubler yin yang, shade each cell light or dark so that cells of the same color are orthogonally connected and each 2 by 2 contains both colors. Each 2 by 2, so no 2 by 2s of colors. In other words, dark cells have double their digits as values. Light cells are unaffected. Equal split lines. Dots split lines into segments with equal value sums. So the dots will be our um, kind of like region lines, except the dots will divide, not the boxes, if I'm understanding that correctly, which I think I am. So we're gonna have doublers for sure somewhere in that bunch, aren't we? So these three digits will have the same value as all of those, which seems probably quite maximal. Here too as well. Okay, so first off, we can say some things that I'm sure somebody can think of right off the bat, but not this guy. But we are having a yin yang. So whenever we know where it starts, and perhaps we can get the perimeter figured out, I'd like to think that these have to be doubles. um, what if they are not? What if none of these are doubled? Then it would be 24. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Dot split lines into segments with equal value sums. Values. Oh, but digits may not repeat. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be all the digits from 1 to 9. Although the values can repeat. So there could be a doubler on here, for instance. But the digits themselves cannot. So this will be 9 unique numbers. Which means that these three cannot be there. Cannot be in any of those highlighted ones. And also these, none of these can be there. There's probably gonna be a trick to that somewhere. So this cell here, okay, that cell only, alright, let's start doing this. So this red, it cannot repeat on this segment. So it is there or there. And then it will be in one of those. Do I get that with anything else? this is obviously going to have to be, one of these are going to be a doubler, and then one is not. What else can we cook up here? This one. Cannot be. This one cannot be in any of those or any of those. Cannot be in any of those either. That one is not quite giving me a column though, not quite. Are any of the other ones? Well, this cell, it's obviously not going to be on those as well. Oh, if I color these, it's gonna make it awfully hard for the yin yang. Maybe I just try to remember that this one has to go in one of those. So I don't really see it going any further at the moment than that. This one as well. Well, what about this one? Not too much. Okay, then let me think about this as far as this line. Because if this line, there obviously has to be some doublers somewhere, or else we're going to be summing to 45. Because they are. So that means, that just simply means that these are doubled. Because, you know, in this, let's see. Don't really have a 2x2 here, but well, actually, I guess all of those could be one color. No, they can't, because it would isolate these. But I do think that these have to be doubled, because I'm pretty sure that something on this line will be doubled. And even if they're all not doubled, if they're all the light cells, then the sum would be 45. And the highest these can be without doubling is 24. So these are gonna be dark cells, which I'm gonna do this one, I think. And maybe I just do a gray here. What does the other color look like? That might be okay. So anyway, it can't be a 2x2. But then the yin yangs are going to touch. Right? As in, it had to get out. Did the yin, what, actually, hold on. I mean, that's true, isn't it? Let me think on that. In a yin yang puzzle, once you swap a color, you can only swap back one time, or otherwise you're going to end up with a region that cannot reach its buddies. So if this were to be white, it would either go all the way around, or it would go back to the dark somewhere and then go all the way around. Once we've had one color swap and go back, then we know it goes all the way around. But these are also yin yangs, but they're Now I'm forgetting if there can be like a dead end. I think that would be okay though if it was. As long as all of the dark squares were orthogonal to all of the dark squares. Pretty sure that's right. So I can't say for sure that these darks come out, but if they did, you can see that these two would have to be relatively small, because even if these are 7, 8, 9, we have a 48 maximum. And since all of these are different digits, we're going to be looking at least 45, which means the 3 or the 2 and the 1 are the only ones that can be doubled. Or did I say that right? I think I said that right. Because the light squares are unaffected, as in we are what if these are 8, 8, 7, 6 is 21, that would be 42. But then we could have, right, see, and that would be broke, because already we're above 45 on this side. So 986 though. 986 is 23, that would be 46. And then the 1 would be the only doubled one on this line, which would mean somewhere there would be one gray one and the rest would be white. Is that too absurd though? It would be too absurd for these 3 to be white. But if this one and this one were to come out, they would have to be 1 and 2. And then, so that's not correct then, because that would be forced to make a 2 by 2 white square. So it does not come out, or well, at least both sides do not come out. The most dark can pick up is 2. But look, it can't pick up those 2, or it'd make all those white. It can't pick up these 2, or it would make all those white. It needs to pick up at least 1. Can it pick up this one? If it picked up this one, it would have to pick up... Oh no. Okay, how about just... Can it pick up this one? If it picked up this one only, and that was white, then it would have to pick up 2, which would be that one, I guess. But then it would have to go this way, wouldn't it? And then it would be stuck. So I'm gonna say that has to be white. And if we were to make... And this cannot checkerboard. In a yin-yang puzzle, you can never checkerboard. Or you would end up, say if it was, this is a checkerboard, then no matter how I connect this one, no matter which way I go over to connect it to this little 3L, then these two are never going to be able to touch, right? Even no matter how I come around, whatever, it's gonna block it off. So this one is white, and now this one definitely has to come out, and that's probably the only one that it's gonna get. No, look, it can't. It will grab one of those because these cannot both be white. Now it could be this one. It has to get one of these, and that will be the only one it can get. So all of these over here are white. Now this cannot be light. It will need to be out to touch its friend, so it does get that one. And then it must turn down, because we cannot have... We're maxed out here, basically. We're at 48, and now that we have 2 on here, then we know that they are 1 and 2, because all the other values are going to be normal. So this is a value of 3 normally, but it's doubled to 6, so it's going to be 3 more than 1 through 9 added up, which is 45. So these are going to be 7, 8, 9, and these are going to be 1 through 9 with 3 added twice, so 45 plus 3, 48. 24 times 2, 48. So this one is white now as well because of that. We cannot have a checkerboard here. Okay, and now what I was saying was, if we go back to gray anywhere, then gray will make wherever it is. I'm not saying it's here, but even if it's over here, right? If these are all white and this goes back to dark, then dark will have to do a complete ring around the rosy, if you will. This cannot be a checkerboard, so it is light. And gray's like, where's my buddies at? So he needs to come out there. And so these have to be 3, 4, 5, or 6. Well, I mean, all of those do. Is that neat yet? I don't think that's neat yet. Gray could just go here, and then white could circle everything also. That is a possibility as well. I doubt it would be that easy though. One of these, I can't forget, must be dark. Okay, so one of these will have to be, this one is definitely going to have to be doubled. Like, there's just no doubt about that. Even if we had a repeat of 1, we would still have 2, 3, 4 on there, and that would be 9, 10, 11. We can't put an 11 here. So it will for sure be doubled. This one, that one is debatable. These two, one of them is unchanged. So maximum we could have 18 if this was a double 9 plus 8, 26. I guess that would be doable in that many digits though. Okay, so what do we think up here? If these two are doubled, the highest this can be is 18. That doesn't seem too crazy. This one is going to be 4 digits long. The 1 could repeat though, so I mean, honestly, Oh no, it cannot repeat. Wait a minute. Forgetting the rules. Numbers on the lines cannot repeat. So this is minimum 10. So that's going to be doubled. And what I say earlier about double 1 or whatever, that was nonsense too. So these are 15 minimum. So that means and 15 cannot be doubled by one number. Or what I mean is, what I mean to say is, since these are a minimum of 15, then 16 is the actual minimum. So these are 8 or 9. And that's a little bit interesting. Because if these were 1, 2, 3, 4, 5, because one of these have to be doubled. But 15 has 4 digits of play though. Or no, it has 3 digits of play. To 18, right? So, but basically what I'm saying is, oh, it's again a 3 digits of play. But if it goes over, it cannot come down. Because 2 is once again the maximum amount that dark can have. And that would be with a 1, 2. That would be 15 plus 3 again if that was 1, 2. Which would be 18. And that would be 9. Therefore, no, they're 8 or 9, actually. Not 4 at all. Does that need doubled? Oh, that I was saying that was B26. If this is dark gray, we go all the way around. Will that break anything? That may break that bottom one. Would that break this? No, maybe not. I imagine those could probably be. It might be okay, actually. I don't think these can be both normal, can they? If they were, 17 would be the highest. Then there could always be doubles on here. For 1, 2, 3, 4, 5, 6. I mean, that can be 21 on its own. Oh, that would be 21 on it. Oh, right. So this has to be doubled then, doesn't it? 1, 2, 3. If none of these are doubled, then it has to equal at least 21. And if this right here is not doubled, it can only reach 17. So that does have to be dark. And now that we've swapped back to dark, like I was saying earlier, this does in fact have to go all the way around, like such. And now these are light, and light has to get out. This is light as well. We cannot have 2 by 2s. Both these corners will be light. This one could still be dark though, because one, 2 could be here. So I think these are gonna have to be fairly small, but I don't think that they have to be super small. If they were 1, 2, this would have a value of 6, and then we would have 3 and 4. So 6 plus 7 is 13, and then that could be like a 7 or whatever, with a little bit of alteration down here. Okay. Oh, we cannot have a checkerboard here, so that is light. Gray kind of... Oh, I don't know if I like this light color all of a sudden. I think I'm gonna keep going with it though. Or should I just flip these to dark? Is that too much? It may be. Okay. 3, 4, 5, 6. Okay, this is going to be one of every digit. Oh, this digit. This digit though could be up here. Otherwise, it would have to be there, but this will have a 7, 8, or 9 on it. These two could be there. And one of them could be there. One, two, three, four. If this is dark, this one would have to be dark. That would be light, which is fine. Yeah, that would be okay, I think. One of these is dark. If this is dark, that would also have to be dark. If this is light, that would be dark. Dark doesn't all of a sudden matter much anymore because it's done the ring around the edge. What about this one being doubled? I don't think that side's interesting yet. These cannot both be white. If this is dark, then these are 1, 2. That would not be... That would not be that big of a deal that I can see. These would be 3, 4, 5. Or, well, not necessarily, but... Oh no, I guess it would be. Because that would be maxed at 18. So we are looking at... If this is a 1, and this was 2, 3, 4, 5... Well, that would be 8 down here. That would be 16 if the 1 was doubled. But the 2 can also be doubled. Oh, well, this is a 1, 2 either way then, isn't it? Oh, wait, we can double a 3, can we not? What about this shader? Shaded slide cell so that... I don't think there's a limit to how many times a number can be doubled. So what was I thinking about? If this was a 3 and all these were white, which would be 1, 2, 4, 5, 9, 11, 12, plus 6, yeah. So a 3 could be doubled. But this is 1, 2, or 3, isn't it? As in a 4 doubled with everything else minimum is gonna be higher than 18. One, two, three, 5 is 18, 11 plus 8, right? Should be 19. Okay. So these two, 1, 2, cannot be on those. I don't think they're gonna be on this one. And I also don't think they would be on this one. Ah, right, they can't be on this. They can't be on this one either. Because even if these were. Because that would only be a max of 9, 10, 11, 12, 13. Right. So these are 1, 2. They cannot be on the split line again. They can obviously not be on the same row. And they cannot be here because the math won't add up. These are, in fact, at minimum 21. I don't think they could be all, they can't all be white anyway. One of these will be doubled. So this has to be a pretty high number. And probably this one too, to be honest. I would think so. Because even if this was a 9 at giving 18, that would only have to be a 4, wouldn't it? But again, all of these can't be light colored, so it would have to be higher than 4. And one of those are dark. But 1, 2 is up here. Whatever that is worth. And this was 16 or 18. Which is basically saying that all of these are under. Can a 6 ever be on this line? 1, 2, 3, 6. That would be 12, I think. 1, 2, 3, 6, 12. Oh, well, no, because then this one would not have a fill. So it would actually 2, 3, 4, 6, which is 10 plus 5, right? 15, 15, 16, 17. Well, it would be no, right? What about 1, 3, 4, 6? That'd be 14, 15, 16, 17, 18. Maybe. But these can definitely not be 7, 8, or 9. Don't know if that will put 7, 8, or 9 there, though. It'll definitely put these two over here. This one could for sure be in one of these, though. I think this one is probably going to be that. Definitely getting a lot of small digits worked around here. Well, not yet, but does this need to be doubled? This one will be doubled. Unsure about those. This could be a low number, though. 3 digits can equal as low as 7. So, I don't think saying if this was a regular 9, I think that would still be okay with the double. Even if it was a regular 8 and that was like a 1, this could be 3, 4. Or that would be 2, 3, 4. So that would be 9, but it could be 2, 4, and then this could be 8. Okay, so no luck there yet. Can this be dark? If this was dark, that would be light. Both these can be light though, can't they? If this is light, then that has to be dark. If this is dark, then that has to be light, and then that would have to be dark. So it didn't make a checkerboard. Alright, if this is light, that is dark. If this is dark, that would have to be light, and that would have to be dark. So that's dark either way around. Don't know if that helped. Well, both of these can't be dark. It still doesn't help. Because neither one of this set, neither one of the top set or the bottom set is really trapped, per se, at the moment. But one of these, at minimum, have to be light. The other one can be dark, but they could both be light. If they were both light, this one would be getting trapped almost, and would have to come over here and then go down. That is if both of these are light. That one would be light. We definitely have some choices going on here. What about this? Because 2 of these are doubled. If this was 1, 2, what did I even say? That would be 6 plus 7, which is 13. So this would have to be 7, 8, or 9. And then these would have to be 14 at the smallest. Okay. So this is one of these. And one of those. This other one is one of these. Probably not one of these. 789 cannot go here in the middle. So this one is for sure one of those. And over here. The other one of these cannot be in the middle here. So they'll go there. And then my question is, can they be here? And I don't think that they can. If this was 7, and this was 1, 2, that would be at 13 already, with 3. Oh, I guess it could. That would be 16. So that could be 789, I suppose. Okay. What about where they go on this line then? So these two, these, these two up here at the top can only pick from those 3 cells to go in. This one can pick from those. That means one of them is here, doesn't it? This one picks from those 3. Oh, I guess those 2 could go there and this one could go there. Oh. And then the cell would be in the middle. Okay. What about these then? This would be 18 and whatever I said. What these are going to be higher than 21. This line. So if it was 9, 18, it would have to be at least 4 to get to 22. I'm unsure about that. Alright, then what am I missing? This one is doubled. If it was low, those could be low. This could still be a normal digit. One of these are dark. Can it be that one? It can't be both of them. Um, the double digit, hmm, it could be odd or even, couldn't it? Yeah, okay. If it was here, this one would have to give, then this would be white. Let's just do a little test. If this is the dark one, this is the white one. This would have to be white. One of these would be gray, one of them would be white. That is okay though. This would be dark. And then we're kind of, I mean, it's still all doable. It would force a 1, 2, and whichever one of these were dark, but that's alright. If this was gray, I don't think we'd have an issue either. Or, I mean, I don't think we'd get much more, progress going. If these are both white, then gray has to come this way and go down, and then we're kind of get lost there. That would be white, yeah. Not much more to really say about that. These cannot both be gray though. Um, I don't think that's enough to say anything positive. So what am I thinking here? Whatever this is. So 2, 3, 4, 5 is the minimum, which is 9, 10, 11, 14, 15, 16. It was right to say we couldn't have a 7 though, I hope. 7, 8, 9, 10, 11, 14, 19. That is true. Okay, we cannot have a 7 on this line. So the high number here, or rather, this one goes here and here. The other one, the other high number, also goes in this column. And then in one of these. This one, it could go in that one as well, but it does not have to. If it went in this one, oh, if it went in this one, if this one that's in the middle, because these two have to go in here, if this one goes over here, then it is going to be on one of these. But this one can have a 7, 8, 9. This one cannot. So it could go there. If that was 7 plus 6 would be 13. 13, and then a 3 would be 16. And that could be 8. Close. If it could not go on this white cell, wait a minute, one of these is this one. It has to go there. one of these that's not that one also has to go here. So there's going to be a 7, 8, 9 in one of those, and then this one, if it has to go over here, but it could still go there. That could be the 7, 8, 9 from this side. This could be the 7, 8, 9 from the middle, if it went over here. Or it could just, all three of them could go over here. Oh, this is tricky. His GDC puzzle though, and I think his usually are tricky. And that is quite alright. So, am I thinking about... Maybe I'm thinking about one of these. If this one is doubled, it has to be at least 3. Which is adding... that would be a minimum of 24. And then this one would be a maximum 18. So this would have to be at least a 6. Can this be... Can this be a 6? It cannot be a 6, can it? If that was a 6, it would be 12. With 9 here at the maximum, giving it 21. But we know one of these are going to be doubled. So this is a 7, 8, or 9. Minimum. But I think I also said this cannot be a 7. We have a combo here. And I said this would have to be at least a... If it was 18, would have to be at least a 4. That is a 4, 5, or 6. But which one is it? 18 plus 4 would be 22. That would put a 1 in the gray spot down here, so it would have to be there. And it would also mean that that would have to be gray. That would be white, that would be white, so that would be gray, that would be white, and that would be white, and we would have a checkerboard. Because if this was maxed out with a 9, and we had a 4 here, that would be 22. So there would have to be a 1 in one of these that are doubled. It can't be this one because 1, 2 is already there. So that would be gray. That one would be white. So that one would be gray. So that one would be white. So that one would be gray. And then both those would be white. and we'd have a checkerboard. Right. So that cannot be a 4. Can it be a 5 then? This would be 1823. Well, 23 is not going to be doable. So will 5 work with 8? No, that would be 21. So this is a 6. This is only a 6. And I think it maxed it out too. Because 8 would be 22. And then we would run into the 1 needing to be the dark color. And it would send this into that. Because again, this one would be white, so that one would be dark. This one would be white, and that one, so this one would be dark. Yeah, so we'd have the bouncing around. So this has to be 9. And now we get a 9 here. And a 9 will be down here. And I don't think that it can be here. So the number we're going for is 24. And that's going to be 3 more again. So it can still be a maximum of 2. There can still be 2. It's a 1 and a 2, or a 3 that's getting doubled. 1 or 2. Well, a 1, 2 has to go on this line, doesn't it? Is it still 1, 2, 3, 4, 5, 6? So one of these are doubled. And even if it's a 1, no, there could be a higher number than a 6 on here. If like only a 1 gets doubled. Okay. A 6 is down here somewhere. If the 6... Oh, what about 9? It's gonna give us a 9 here, isn't it? That is correct. 9 is there, so now we have an 8 here. And that may do something. Oh, and a 9 cannot go on this middle, for sure. 9 is in one of those. 9 will be here. I don't think it can go there. 9 plus 6. No. That would be too high. So the 9 is here or here. Not be in the middle. The 8 is now 16. And this was 15 minimum, wasn't it? So we are doubling a 1. So that gives us it gives us this little makeup, and it also tells us that those have to both be normal light, and these are 2, 3, 4, 5, which would be 15 plus 1. So those are all 2, 3, 4, 5. The 2 cannot be here, or else it would have to be in the middle. So the 2 is in the middle, and then in one of those, likely the doubled one, because I do think that these are going to have to stay fairly small. If this was a 1, 3, we'd be at 8, 9, 10. I mean, that could be a 4. Actually, this number cannot be 2, 3, 4, or 5. Wait, is that nonsense? This may have to be a 1. No, it could be a 6, couldn't it? It can't be 2, 3, 4, or 5, though. Because no matter what, it's going to take away... It sees all of these. So, this cannot be... What can it be, then? It can be a 1, 6, or 7 at the moment. If 1 goes here, this would now be a 2, 3 at the minimum. 10, 11, and then 15. Well, I mean, maybe. But I did remember this was able to be a 7. Okay. What did we get last? We got this last, I think. We have our total for this. Is 2 being normal here? I think I just checked where that would be. That could be 1, 3, 8, 9, 10 with a 6 and be an 8 there. That would be fine. Who knows? Not I. This one, does that need doubled? Maybe not. One of these will be doubled. Oh, this gray here. This gray is trapped. Because that white had to go up. So now this is gray. It does have to turn down. Because it can't own both of those. So that is like that. That light white probably isn't the best decision. Maybe I can pick a different... Can I do a green for that? Green is my normal numbers. Dark is doubled. Green is gun touched. Alright then. So. Oh, that could be either one. Oh, if this was green though, it would force dark that away. This would be, both those would be green. That would be dark. That would definitely be okay for that one to be doubled and those to add up to it. One of these is dark, one of them is green. Or actually, I think both of these would, oh no. We can still have 1 and 2 dark on this line, but they would have to go here and probably here. And that would be 1 through 6, 21 plus 3, or the 3, wherever it ends up, if it's on this line. Well, it will be on this line. The 3 could just be doubled. And it would be in one of these spots too. But it could be that one, instead of having to be that one. So it's either 1, 2 like this, doubled, or 3 in one of those. Tricky. What about 7 and 8 then? They're now a... Oh, so 7 and 8 have to go here. What am I doing? 7 and 8. 8 is now here. And that's gonna give me other stuff, isn't it? A 6 will go in one of these. 3, 4, 5, 6. I'm missing. 3, 4, 5, 6. Okay. I guess that's it. 7, 8. So one of these is down here. I think 7, 8 could be on these. Can 7 be on here? And it would be instead of what? It would be instead of the 6. That would be 22. And then the 1 could just be doubled right here. Alright, sorry about that. I had to pause real quick. We are going to have... Oh, what is this? I have a 1 down here. I just saw that. Am I not doing Sudoku? That is very, very possible. A 9. I think thinking about all of the things, I just forgot to do Sudoku. And then when I answered a question and looked back, I was like, I saw these 1s right away. Okay, so this could still be a 1 though. 2, 3 being doubled would be 10, 11. Yeah, and this could be like a 6 or something. Right. So these are 3, 4, 5, 6. What is that telling me? It tells me that this one goes here. And it's 3, 4, or 5. Well, let me just mark that. 3, 4, 5. This is 3, 4, 5. 3, 4, 5, 6. Oh, this one cannot be... Oh, yes, it can. This one can be 3, 4, or 5. This one is probably... Yeah, this one is one of these, isn't it? Yeah. Okay. But this could still be a... Well, this is a combo, for whatever that's worth. Is that worth anything? And maybe not. This can be 6 too, though. What am I doing? Now it's not a combo. This one, though, is whatever that one is. So that is a 3, 4, 5. And now it is a combo again, isn't it? 2, 3, 4, 5. So that is... Am I thinking about this correctly? Whatever this is still has to make an appearance over here. It cannot be on that line again. It would have to be there. So that is a valid 2, 3, 4, 5. Could not be 6 because then 6 would not be on this 9-digit line. Values may repeat, but digits cannot. So that does make that a 6. And now we have 3, 4, 5 going on there. This 2, 3, 4, 5 is still good. This is not a 6. Now we also have a 3, 4, 5 combo going on here. Now, if this was not 2, if this was not 2, this would be an insta 12. If it was 6. Okay. If this is not 2, then it cannot be 3, 4, 5. And 1 is right here. So that would be 12, 13, 14, 15, 16. And no way to make our number. So that must be 2. Because it could not be 3, 4, 5. So we're at 4. If this was 1, we would be at 5. That would have to be a value of 6 if it was a 3. So we'd be at 11. That's still doable. That could be a 7. That could be a 9. If this was 7, we're at 11. This could be 1, be 13. Oh, okay. If this was 7, we would be at 11. This would have to be a 6. Which would be 17 already. So we cannot make 18. So that is a 1. No, it's just not a 7. What did I have 1 or 7 there for, though? Alright, well, this cannot be 1. No, this cannot be 2, 3, 4, 5, 6, 8. No, it is a 1. I just said it couldn't be a 7. 8 is right there. 9 was way too high. 2, 3, 4, 5, 6 are all in the column. So that is a 1. And now this has to be at least a 3. That would be 10, 11. Okay, so Well, can that be a 4? That would be that would be 12, 13. No, I guess it can't. If that was a 4, it would be 8. No, 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 no. If this is a 4, or it's 6 times 2 is 12, 13, that would have to be a 5. And it can't be because it's in a triple in the column. So that cannot be a 4, so therefore, haha, it has to be a 3 because it cannot be 1 or 2 because they're already on this side of the region sun, or the split line. So this is 5 times 2 is 10, 11. We can't have 3, 4, or 5. We can't add up to 17, so it has to be a 7. And now this has to be a 9 to make 18. Let's double check our math. We're at 10, 3, or 5 times 2, because they're doubled, is 10, 11, 18. 9 times 2 is 18. 18 equals 18. We get a no 3 there. So we also get a no 3 there. So 3 is now sure in there. It is out of there. So it is for sure in there now. And in one of those. Okay. Okie on the dokie. So 7 is over here then. And there. And this will now be 8. 8 will be over here in this column and right there. And then it will be over here. Okay. 1, 2, 3, 6. It's going to be over here and over here. And which makes 7 over there, and then with what number? With this one. 4, 5 will be with it. Whatever's not in this column. Can I figure out that column? I guess not. Shouldn't I be able to? Oh, no, I guess not. It's just whatever number this is also that number, and then paired there. It just looks very confusing. I do think it's still accurate though. Okay, so did we do more maze? Is there more Sudoku to be done? It doesn't matter if those are doubled or left alone. There are no lines to force it around. This one is going to be that one. And it'll be down there somewhere. This will have 3, 4, or 5 in it, whatever's not. Oh, this one cannot be 1, 2, or 6, or 7 or 8. This is 3, 4, 5, isn't it? Three could be the double digit. And that would be, can all of these be white? Or green, rather. And that one be dark. Both of those would have to be dark. That would be green. That would be dark. But I think that would be okay. If this is the double digit, if this is the double digit, let's just try that actually. Because that's very confusing when I do that. If this is the double digit, it would have to be a 3. Those would all have to be green, which means both of those would be double. And it means that would be green. It means that would be double. But nothing there looks broken. Okay. That way, nothing looks broken. If it was this one doesn't have to be low though. So I don't think I can really check that one yet. Might leave it alone. But it could still be 1, 2 here though. It could still be 1, 2 right here. And it would have to be right here only. Getting doubled. I can't forget that. But it could also be 3 here getting doubled. And I'm just not sure. What is this? 1, 2, 3, 4, 5. And that's it. Oh, okay. Okay. This cannot be 3 because of this. So it cannot be 1, 2, 3, 6, 7, 8, 9. So we've made a 4, 5 combo. So that is 3. But at the same time, this could still be 1, 2 being doubled. If 3 is doubled here though, then it doesn't really matter. Well, let's do a test. Say it is those two. All of these would be white. That would be... Those two would both be gray. Oh, and we have a checkerboard. So that is broke. So these two... But what if it had a number that was higher than 6 on it? What if it was 1, 2, 3, 4, 5, 8? That would be 23. So that wouldn't work. But 1, 2, 3, 4, 5, 7 would be 22. And then only the 1 was doubled right here. So if only the 1 is doubled, and these are all green, then that would have to be green as well, or we would get another checkerboard. Okay. Okay. So that one is the double digit. I think is fair to say now. And 1, 2s can go anywhere on this line now, except they cannot be there. So 1, 2 is down here somewhere. But 3 being doubled means that it is 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6, which is 21, plus 3 again for the double, which is 24, which is 18 plus 6. Okay. Okay. So this cannot be an odd number, can it? No, it cannot. So it is 2, 4, or 8. And this one will double up to it. So it is not 2. If this, so this is a 2 or a 4. Oh, and it's not a 4, because we already have a 4-5 combo up there. So that is a 2, and that is a 4. That gives us a 1 there, a 2 there. It gives us a 3, 5 there. Which is not quite a combo, but getting closer. 7, 8. 4, 5 is here. Okay, that one is still a 4, 5. Okay. So this one cannot be... Oh, this one might be a bit limited. It's a 1 or a 5, isn't it? I don't know if... I don't think 5 is quite limited in other places, though. 3, 4, 5. 1. Oh, 2. 2 cannot go here. 2 cannot go there. 2 goes right there. It's the only spot it could go. Now this one is not 2, which makes 2 here. And now, well, we got a 3, 4, 5, but I think we've always had that. 3, 4, 5. These are 6, 8, 9. What do I got the side marks on there for? Just because I never took them out, I suppose. 8, 7. Okay. Do I get any more for way of the yin yang? Yeah, I do, because all of these are green, aren't they? And with those all being green, we're gonna get a dark here, a dark here, and a dark there. Those all have to be dark. This one is finding its way out to its buddies. That is good. Green needs out right there. This cannot be 8. Could have taken... Oh, wait. Oh, yeah, that's true, that's true. Basically nothing on these can be higher than 6. Okay, let's mark them. 1, this is 1 or 5 as well then. Oh no, it can be 6. Okay, this one cannot. 1, 2, 3, this one is 4 or 5 only. Making a combo in the row. This one cannot be 1, 2, 3. This one is 4, 5, or 6. Okay, so 6 has 2 choices. 4 has 2 choices. 1 has 2 choices. Okay. Now what? Oh, it's 4. Mm, I'm not sure on that. If 4 went on this line here, oh no, I don't know. If 5 went here, if 5 went here, that would be 1, that would be 6. This would be 4, 5. That would probably be okay. Six is in one of these. Might as well mark it. 4, 5 is just a combo, so whatever doesn't go here, 7 or 8, will go there with 9. There will be a 3, 4, or 5 up there. It could be any of those. 1 is definitely here, so 1 is definitely down here. Is 1 gonna be a double digit? It could be. This can be an 8. This would be 2. Could that be 6? No, it cannot. The highest digit this can be... Oh, but this could be a doubled smaller digit as well. These cannot both be gray. I'm sorry, they cannot both be green. So one of these are getting doubled as well. And the minimum digit being a 3. Because 1 is seen, 1 and 2 is seen in row and box. So say we had 3, 1, we'd be at 8 already. So this is definitely getting doubled. That is doubled. Green needs out. He's like, hey, that is green because of the 2x2. At least one of these are gray. If it's that one, that would probably be alright. Green would touch there. Can that still be 16? Probably so. Could be a high number getting doubled up here. That would be okay as well. This is a normal digit. Both of those could be normal. But that's alright. This sees 1, 2, 3, 4, 8, 9. This is 5, 6, 7. No, this is only 6 or 7. 4, 5 is in a combo. Wombo above it. This is 6, 7. 6, 7, 8. It's all in there. Oh well, that's okay. So one of these is there. One of these is there. That's okay. This cannot be... Oh, 3. 3 is in the middle. 3 has to go there. Now we know that this has to be doubled. There is absolutely no way that this does not equal. Now these are 1, 2, 3, normal. And 2 can only go here. But they're all green though. Now this one has to be gray. green one's out. This green is not trapped. This can still be either color. But this is 1, 2, 3, and 2 has to be there. And this will be 1, 3, so that one is 1, that one is 3. And now we have 6 equaling 6. And we also get the 3 over here. And what else? We get the 1 maybe right here on the 1 through 6 line. That's nice. We get the 2 in the corner. And 8, yeah. Are we actually going to 16? I think we could. I think we could. Any more on... Well, any more Sudoku? In these puzzles that have me looking at a bunch of lines, sometimes I do be forgetting. Two is looking like right there. I think that's all of the 2s as well. 3. 3. Not much left to do with it, I think. 4 is up here. Might be a tricky bounce going on with 4 or 5. I'm not sure. But anyway, let's see. Oh, we only have 1 4. 4 is in one of those. 4 is in one of these, though. So 4 is going in one of those. And it might be it on 4 for now. 5 I don't think we have any of. 6 we only have a couple. 6. Okay. 7. If 6 goes here, it would go there. Oh, that's okay. Probably. 7. Oh. Not quite. 7 is in one of those. 6, 7's making a... Oh yeah. Got that rope pretty much marked out. I do. What about here? Here we have a combo, so what is this? 9, 5. 5, 9 is combo there, and then this will be a 6 or a 7. But it also means that 5 is over here. With what else? A 6 or a 7. Okay. And then a 6 or a 7. What about this guy? It sees a 7. Sees 1, 2, 3. It can be 4 or 6. Okay. This one can be 4, 6, or 7. Yeah, I don't think I'm gonna make a combo there. As much as I want to. What about eights then? Eight. So one of those, one of those, one of those, one of those. Mm, no good. Nine. 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 Okay. Alright, so then now I need to think. Oh, we're not making a checkerboard here, so that must be gray. Now we're back to maze. Back to, yin yang. I haven't done a yin yang puzzle in a long time, come think of it. We cannot make a 2x2 again. If these are both okay, this is gonna be where we think of then. Can those both be gray? Oh, if it's not, if these are not both, oh wait, can I do that? If either one of these are green, no, I can't do that. I was gonna say if either one of these are green, that would have to be gray, but they could both be gray. That could be green. But can they really both be gray? 1, 2, so we'd have a 3 and a 5 there. And maybe, and a 1. 3, 5, and 1. We'd have 18. So no. If they were both gray, the minimum would be 3, 5, 1. Which is 9 times 2. And we can't have a 9 here because of that one. So these cannot both be gray, which means there will be a green here in one of these, and this little area here will be stranded this way. So that one has to be gray. And we do know that one of these are doubled because we can't have a 2x2. So the minimum is 3, which don't know if that gives me much. If it was 3 and that was 4, we're only at 8. Although this one cannot, let me put minimums in. This one cannot be 1, 2, 3, or 4. So the minimum is 5. This one and this cannot be both gray. This one, the minimum is 3. Okay, so if 5 is doubled, 5, 6, 12, 15, that would be alright. Or would it be alright? Let me put more digits in here. I don't think I'm gonna go that high, but this one is, cannot be 1, 2, or 3. So this one minimum, other than 1, is 4. Would that even be a possibility? Minimum with 4. It would be 3 being doubled would be at 6 plus 8, 14, 19. Okay, 4 is not possible, which means 1 is the only possible digit in that cell, because 1, 2, and 3 are all seen by Sudoku. So we have, now we think of this again. If this one is doubled, we are at 12. But the point is that could be 6, and then we're at 13. Or, no. We'd be at 14. But, plus this. Well, hold on here. If this was 5 doubled, those two would be 12 totaled. Couldn't be with a 3. Couldn't be with a 5. And it couldn't be with a 6. If it was 6 doubled, that would be 7. It would be at 14. We couldn't go with a 3. Couldn't go with a 5. So yeah, this is just, if it was 7, 8, 16. No, this one is just the green one. Sorry about the beeps. I will sort that out right quick. My apologies. I'm not sure if those are heard or not, to be honest, but if you did hear a bunch of beeps there, sorry. Okay, so here is our doubled. What is our maximum? If this is 7, it's going to be way too high. So it is not 7, 8, or 9. If it's 6, we are at 7, 14, way too high still. 10 probably would be as well. 5, 6, 12. Yeah, that is a 3 then. That gives us 3. That gives a 3 here. That gives a 5 there. A 4 there. This one has to be 4. So 4 still is not on this line. It has nowhere to go but there. That gives us all of those. That one is now a 4. These are going to be... These two are basically a 5, 6 pair, but just for the line, I suppose. So what adds up here? We have 3, 4, we have 8 at the moment. So 8 plus 6 is 14. So this is a 7 or an 8 only. And then it's also 8. So 7 will not work. And 9 will not work. It could be in, yeah, so it is 6 or 8 only. That should be good. This cannot be 5 now. We have a 6, 8, 9. Is this 8 only? No, this is still 6 or 7 as well. We do have a 4. Rather, we have a 3, 5 combo. This is now a 4. 4 will be over here with 7. And um, 5 will be down here with 6. So okay. Oh, Sudoku. 3 2s 4s. 6 or 8. It's one of those. I think I need to do some Sudoku probably. 2s are done. 3s. 3 is right there, which will put 3 there and 5 there. Good. That will now be 6, so that will be 5. That will now be 8, so that means we're at 4 times 2 is 8, 16, so that must be 8. And that one is now 8, so that one is 8. And it was scrumptious. So this is a 6 7. Only thing that's left. This would be a 4 6 7, would it not? It would. So it is a 4 6. Then that would be a 4 6 7. Okay. So we continue Sudoku perhaps. 3s are done. 4s. Okay, 5 maybe. 5 is making a combo up here now. This is a 7 or 8. And an 8 is already in the column. So that is a 7. So we get those lined out. This is going to be a 8 down here somewhere, so it is here. That was also Sudoku. Just hadn't got to the 8s yet. 9er. Three, 5. 5 is in one of these. 5 is in one of these two on both of these boxes. So 5 is in this column. In box 7. This cannot be 4 or 7. So whatever this is missing is a 6. Because it was only 4, 6, or 7 in the row, and 4, 7 is right above it, so that was a solution there. This one will be this is a 6, 7, or 9, so that is okay. Oh, it is not. I just put a 6 there, didn't I? Anywho. Nine cannot be here. Nine can be in any of those, so 9 can still be there as well. think, yeah. Okay, one. Are all the arrows, are all of my lines done? I think they are. Okay, now I just do Sudoku then. Twos were done, ones are still there or there. Threes look done. Fours. Is there something going on with four? Don't know what it would be. Five. Six. Six is over here. One of those. And okay, seven. Seven. Oh no, seven could go there. Eight. Eights are done. Nine. Okay. Am I sure that I am done with my doubling stuff? I think I have all of my lines done. I think they should be adding up correctly. Okay, so now I just need to find a pattern, I suppose. Or a combo, probably, is what I'm looking for. Or a cell that sees a whole bunch vertically and horizontally. Or any of the above. Or all of the above. Five went there. Let's try this. If five went here, five, five. Oh. Seven, 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 seven. So that would work for seven. If that was seven, we'd have four here. Four would then be there. We would put five there. I would put nine. there. What was actually broken? Anything? I would put 6 there. I have no idea. I'm not repeating on anything, am I? 1, 3, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything looks good as far as the repeats go. This was right, wasn't it? 8, 10, 14, 15, 16 equals 16. Okay. Oh, is this a 7? Would I have a 7? Oh, that was whenever I did my theory. My theory testing. Let me mark up these, let me just mark all these cells then, I guess. We have 7 on there. 6, 7, 9 is the row. Okay, okay. So what are these? 1, 2, 3, 4, 5, 7, 9. 5, 9. 4, 5, 7. Two, 3, 4, 5, 7. Oh no, 4 or 5. So this one. 1, 4, 5, 7. Hmm. 2, 3, 4, 5. This one can be 9 as well. One, 2, 3, 4, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 4 or 6. 2, 3, 4, 5, 6, 7. Wow, what? Okay. Alright. Combo eye. Time for combo eyes. Okay. Am I overlooking something so silly? Am I forgetting a rule? I don't think so. Just need to find out. I'll tell you what I'll do. I'll look in the correct spot. Oh, this is... Oh, no, it's not. Where is my combo? Four. Oh no, it's not. Okay, then what if that is 6? Oh, is that all it's gonna do? No. Alright. That is 6. These will be 7. And that's broke. There. So these corner marked are not 6. So this one is 7. Wow, that was tough. That was a nice puzzle. I did enjoy the... I always enjoy the ones where we construct something, whether it be yin-yang or tunnels or loops or labyrinths or a lot of this stuff. What else do we build? Sometimes we build, sometimes we help animals out of mazes, etc., etc. Oh, and the chaos or the deconstruction ones, those are always fun. Many different types. Fun stuff. But yeah, very nice puzzle by GDC. Check it out yourself in the link below. Like and subscribe if you enjoyed. Thank you so much for watching. Have a great day and bye bye.